Hi, this is Kumaran. In this video about 8085 microprocessor division of two 8-bit numbers. In the series of programming 85 microprocessor, already multiplication of 8-bit numbers have been uploaded. So the continuation of this I will go through that division of two 8-bit numbers. Before going into the program, let us discuss about the logics involved in the binary division. So for example, we'll take that two 8-bit numbers 8D and 3A. So we'll calculate this in terms of a binary division, what answer we will get. Actually, this logic is not implemented by the processor. Processor will do that repeated division that we'll discuss on the programming. Now we will do the manual calculations 8D. 8D means you know that the binary number for 8D is 8 is 1000. D is 13, 13 is 1101. This is 8D. Then 3A. 3A is 1 is 3, then A is 1010. This is A. Okay. Because 3 is 0011, but before 00 it's no valid, that's why I am removing that. So now we will take how many digits here, the divisor here 6 digit, but here you take 6 digits. If you take 6 digit, it's not possible to divide because here it's starting that 1 but here it is 10. Based on that weightage of the MSB, this one is smaller, this one is larger. So you take that 7 digit. So 7 digit means it's possible to divide. So it becomes 1 times. So you write that 1, 0, 1, 0. So you taken that 7 times. Now you subtract that binary here. 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 0 is 1, 0 minus 1, it's not possible. We cannot divide, so we have to take from here 1, here also no, here also 0, here also 0. So for that you take this 1 and keep it here, it is 1, 0. So we need to take 1 here, so take that 1, 0 means 2. So if you are taking 1, it becomes 1 here. So if you keep here, it becomes 1, 0. Again we want to take 1, so it becomes 1 here. Then you keep 1 here. So 1 means it is 1, 0. 1, 0 is 2, minus 1 is 1. Then 1 minus 1 is 0, 1 minus 1 is 0. So this is the number after subtraction. So let's take that another number here. So now what we have that 0, 0, 1, 1, 0, 0, 1. But here we have 1, 1, 1, 0, 1, 0. So it's not possible to divide. So you keep that 0. Then whatever here, it is a remainder. So here the quotient is 2. Then a remainder is from LSB adjust to 4 bits. This is 1, this is 9. So the answer you will get for this program, the quotient is 0, 2 you will get. The remainder is 1, 9. This is the binary division. Here when you subtract the binary numbers, it's a little bit tricky. If you feel it is difficult, you can take 2's complement and add. So whichever the number you want to subtract, you take 2's complement of the number, add with this number, then complement that carry. Otherwise you don't consider the carry, because always we are subtracting larger minus smaller. The carry will become 1, though that should be kept as 0. So that's the logic here. So this is the manual calculation for 8-bit division. But how the processor we can implement the program, because we don't have direct instruction for divide. If the instruction is available for divide, then only this process will be done. The entire process is done for the instruction divide. But in 8085 microprocessor, as you know that we don't have instruction to perform that divide. So what we are going to do is we are going to perform that repeated addition. So which means we are taking this number into accumulator. This number you take some other register, compare both. If the numerator is greater, then you subtract once, increment the quotient. For example, we will take this number in accumulator. First number you take this in accumulator 8D. Then the second number we will take consider B register 3A. So what we are going to do is take one more register to count the quotient, initialize with the 00. So what we are going to do is we are going to compare A and B. So if you compare A, B, which compare means it's logically a subtract operator. Flag only updated, there is no answer updated on the A. So only flag updated, which is called comparison. So if 8D minus 3A, you won't get carry, isn't it? Because 8D is larger. So what we are going to do is we are going to subtract 8D minus 3A. So 8D minus 3A, what you will get? D minus A is D minus A is D is 13, A is 10, so you will get 3. Then 8 minus 3 is 5. So 5, 3 answer, then increment this 1 because 1 subtraction over. So again you do the same process. You the answer whatever subtracted 53 minus 3A till it is possible to divide. So 53 minus A, that also you divide 53 minus 3A. So 3 minus A is not possible. You take 1 from here, it becomes 4. If you take 1 here, base of the number is 16. So 16 plus 3 is 19. 19 minus A is 19 minus A is 9. Then 4 minus 3 is 1. So then increment the register 1 because 2 times we divided. So now you compare 19 minus 3A, it's not possible because you will get the borrow because this one is smaller, this one is larger. So there is no further division. So update the result. This is 02 as quotient. The remainder is 19. This is what the logic we are going to implement in the program of division of 8-bit numbers. So the same thing we will write the program here. 4200 we will have to take this and have in accumulator. But this number we have to copy to B register. So better you take this number first to B register. So you take that LDA 4201. Then copy this to B register as per our algorithm. So move B comma A. Then you take the second number in accumulator LDA 4200. Then we will initialize the C register to count the quotient. Move immediate because we have to load 00 which is known data, so use that move immediate as 00. So all the initialization is over. Now we have to compare. So for that you do that CMP compare with the B register because one operand is incurrent which is A and B is compared. Suppose carry occurred, use go to store the result. Store is a label, you can give any name here, even your name also you can give. Suppose no carry means what we have to do? We have to subtract once. Sub B register, which means A minus B, answer in A. So every subtraction we have to increment the C register to count the quotient. INR C. So every time you compute this one subtraction, again we have to compare. So you make that unconditional jump to repeat. So the repeat label should be, here you have to compare. So here it is repeat. So this loop will repeat until carry occurs, which means that by this condition, whenever a numerator is smaller than the denominator, then only it will come out of the loop. So we have to store the result whenever it come out of the loop. The quotient is available on C register, remainder is available on A register. So we have to store the result. So a reminder to be stored on 4203. Now the remainder is on A register, STA. The next address you make 4203. Okay. Now you take that quotient is on C register, take to A and use that STA. Move A comma C. Now you store that again STA. So LDA, STA are for reading memory and writing memory for input as well as output. So here we are using the reverse order 03 and 02 because quotient and remainder in that order we have to store. This is our assumption. You can do the reverse also, but accordingly you have to refer the memory for the answer. So this is the program for a division of two 8-bit numbers. Let's compute this in simulator. Let's discuss. So let's open the simulator 8085. So you know that how to perform this. Already we discussed one video. So let's go this LDA 4200. So as per our logic 4201. Then you take that move B comma A. So in the simulator there is no comma, only space. LDA 4200. Then I initialize C register for carry MBI C0. Yeah. Now we have to compare CMP with B register. Jump carry, you store. That's what we used in our program writing. Then we now suppose no carry means we have to subtract B, then increment C. Again we have to check. So unconditional jump to repeat. So the repeat label should be here in compare. So here repeat. Whenever label means use the label colon and space. So after this we have to here the label is store. We have to store the some now we have to store the remainder 4203 as per our program. Now we have to take the quotient from C register to A register. From C to A. Now we store that STA 4202 in the order of quotient and remainder. That's why we are using in reverse order in the address. Stop the program. So that's all about the program, whatever we discussed in this. So same thing here, we will give the input 4200. We given that 8A, then 8D 2A. So that's what we taken 8D 2A. then the output you initialize is 0 0. So now we will see our program compiled. We'll take the first number, second number to B register. See here, B register is copied to a denominator. Numerator is taken a register. We'll compare both. Now the carry flag, no carry. So it won't skip. So it will subtract once. So once subtract, we have 6 3. Then we have so because again you have to check. You check here also no carry, so it will repeat the subtraction. Now it will check now that carry happened or not. Yeah, the answer is stored 3 and F. I think we have taken different input output. Let's take 83A. What I have taken here, 82A I have taken. That's why it's coming different answer. Let's give the same 83A. So we should get the same answer for the given input. So again you compile continuous run. See here the answer 02 quotient 19 as remainder, whatever the manual calculations. So that's all about the division up to 8-bit numbers. I hope it's clear. If you have any doubt and clarification, you comment on this video. I will reply. Thank you.